Good morning, class 11. Welcome back to our online session. So we are in chapter number 2, relations and functions. We have discussed what a relation is, right? How many types of relation possible from one set to another set, how many relations are possible within a set itself, and how to derive a relation from the Cartesian product of two sets. Today we start function. What is a function actually? So you have studied relation. Now, as per the definition, a relation becomes a function. Not every relation is a function, but only the relations such that every element in the domain set, the relations in which every element of the domain set has exactly one image in the codomain set, that particular relation is known as a function. Otherwise, it is a relation. Listen once again. When every element in the domain set, you know the domain of a relation and the codomain and range of a relation. If every element in the domain set has exactly one image, not more than one, every element in the domain set should have exactly one image in the codomain set. Such a relation becomes a function. Now, a relation becomes a function when every element in the codomain in the domain set has exactly one image in the codomain set. Let us understand it better in the form of an arrow diagram. Set A to set B, there is a relation R1. Element A has just one image 1. Element B has just one image 3. Element C has just one image 4. Element D has just one image 5. Okay, but there is an element E in the domain set which does not have any image in the codomain set. This is the codomain set. Since E, the element of domain set, does not have any image in the codomain set, therefore R1 is a relation. It is not a function. Let us come to R2. एलिमेंट A has only one image 2. देखो गौर करो, A की एलिमेंट A has only one image 2. एलिमेंट B also has only one image 2. C also has only one image 2. D also has the same image 2. Element E has another image 4. Every element A, B, C, D, E, these are the elements of the domain set. They have exactly one image. See, more than one elements in the domain set can have the same image, but one element in the domain set cannot have more than one images. So this is a function. R2, relation R2 is a function. Let's take another example. Element A has two images. A की दो इमेज है, एक 1 है, एक 2 है. What does the definition say? Every element in the domain set should have exactly one image. एक ही इमेज होने चाहिए. डोमेन सेट के एलिमेंट्स में, एलिमेंट्स इन द डोमेन सेट, मोर देन वन एलिमेंट्स कैन हैव द सेम इमेज, बट वन एलिमेंट cannot have more than one images. A is having two images. So this R3 is not a function, it is a relation. Here, every element in the domain set has exactly one image. कोडोमेन सेट में कोई भी एलिमेंट अनएसोसिएटेड रह सकता है. Any element in the codomain set, every element of the codomain set may or may not be the image of an element in the domain set, but every element in the domain set should have exactly one image in the codomain set. Only then the relation becomes a function. So here R4, this is a function. This relation R4 is a function. So we can say every function is a relation, but every relation is not a function. Which relations become function? The relations in which every element in the domain set has exactly one image in the codomain set. Okay, now अब जैसे इसकी आप बात करोगे, ये relation R2, it is a function. So if I ask you to write the domain of this function, So A, B, C, D, E. Domain of the function A, B, C, D, E. Range. Range is 2 and 4. That's it. कोडोमेन सेट, पूरा सेट B कोडोमेन सेट है, बट जो इमेजेस है only those elements will be in the set of range. Okay, now this was the simple definition of a function to understand how a relation becomes a function. Okay, not every relation is a function, but this is for sure that every function definitely is a relation. Now you have types of functions. Number 1, polynomial functions. Now polynomial function can be many types, like linear constant polynomial. Constant polynomial in grade 9, in grade 10 you must have studied polynomials. Constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial, polynomial of variable or single variable. So constant polynomial function f of variable x can be written as f of x equal to k. What is k? K belongs to R and k is not equal to 0. For a constant polynomial, k is not equal to 0. Next, linear polynomial. A polynomial which is in the form f of x equal to ax plus b, where a comma b belong to R and a is not equal to 0. This cannot be 0. अगर ये 0 हो जाएगा, the coefficient of x is 0. You will not have a term containing x. So this will not be a linear polynomial. To be a linear polynomial, the variable should have the power 1. The highest order of the highest power of the variable should be 1. So this is a linear polynomial. You have quadratic polynomial. F of x equal to ax square plus bx plus c. A comma b comma c, they are real numbers and a is not equal to 0, because if a becomes 0 you will not have the term containing x square. In that case, since you don't have x square, how can you call that expression to be a quadratic expression? So this will be a quadratic expression if and only if a is a non-zero constant, non-zero real number. So polynomial functions, these are all polynomial functions. You can have cubic polynomial, you can have biquadratic polynomial. Okay, so based on the degree you can have as many polynomials as you want. Next you have trigonometric functions. See children, you have studied trigonometric ratios. Trigonometric ratios like sine ratio. If there is a ratio, there has to be a particular angle. Sine ratio of angle theta. If I replace this theta by a variable x, this becomes sine x, where x belongs to R. X is a real number. So now this is a trigonometric function, because to be a function it needs to have a variable. Unless there is a variable, you cannot call it a function. So f of x equal to sin x, f of x equal to cos x, f of x equal to tan x, and so on. These are trigonometric functions. Next you have logarithmic functions. I hope you must have been introduced by the term logarithm in your previous classes. हो सकता है आपने फिजिक्स में या केमिस्ट्री में कहीं पे लॉगरिथम्स पढ़े हो, या मैथमेटिक्स में भी हो सकता है आपको प्रीवियस क्लासेस में 9th में स्पेशली लॉगरिथम बताया गया हो, या 10th में लॉगरिथम इंट्रोड्यूस किया गया हो. अगर नहीं है तो वी शैल डिस्कस इट लेटर, नॉट एट ऑल एन इशू. f of x equal to log x. Now this x is the variable. log, log stands for logarithm. There are two types of logarithms that we have in usage. One is natural logarithm, another one is decimal logarithm. Okay, I will explain you. I will have a special session on just logarithm, because children, if there is any student in this grade 11 who aspire to appear in the examination of this triple E or JEE or mains, whatever it is, you will have to know what logarithms are. So I will have a separate session. If at all you have not been introduced by logarithms by the previous teachers or in the previous classes, I will have a separate session for logarithms only. Okay, then I'll explain you what a logarithm is, how to use logarithm. This is actually a mathematical tool. Okay, it is used to disintegrate the exponent. To the best of my knowledge, in grade 6, 7 and 8, you have studied exponents and radicals. So whenever there are exponents of higher order, we use logarithm to evaluate them. Okay, we use logarithms to evaluate them. Anyways, then you have modulus function. Modulus function is also known as absolute valued function. See children, there are certain quantities which are always absolute. Absolute means non-negative. For example, I'll tell you, since you are mathematics students, you should know one thing. Say A and B are any two real numbers. A and B are any two real numbers. Now my question is, how will you represent? How will you mathematically represent a statement? My statement is difference of A and B. This is a statement. This is a clause, a phrase, whatever it is. Difference of A and B is an odd integer or is an odd number, or difference of A and B is an even number. Right? So how will you represent the difference of A and B unless you know? I say A comma B are any two real numbers. A comma B belong to R. Difference. Always remember children, in mathematics, difference is an absolute quantity. Difference is something which is never negative. It is always positive. So difference of A and B. Difference between any two numbers always means number of higher magnitude minus the number of lower magnitude. Now unless you know whether A is the number with higher magnitude or B is the number with higher magnitude, you never know whether we have to write A minus B or B minus A. So to eliminate this confusion, because we are unaware, we are completely unaware about the values of A and B. So in such cases, to eliminate the error, we use modulus, mod of A minus B. Now, even if A is smaller than B, A minus B, A is smaller, B is larger. So A minus B will be a negative quantity. To nullify the negative effect, we use this sign of modulus. We make it absolute. So difference between any two real numbers A and B is represented by mod A minus B. Okay? So modulus function f of x equal to mod x or mod x plus minus a. Mod of A, where A is any real number, or it can be mod of A plus minus x, whatever it is. You can apply modulus to any function. Modulus can be applied to any function. So in this way we have many types of functions which in the coming classes we will discuss. For every function we will also discuss the domain, the range of the function, how to plot the graph of the function, and how to find the domain and range of the function. Is it a real valued function or is it just a real function? There is a huge difference between a function to be called as a real function and a real valued function. So for every function you need to have a well-defined domain, and then you have the set of images, that is the set of range. So all these things we shall discuss in the next class.